was under 3 papers instead of just 1. So, there we go. Backlight switch for me. Is the special right triangle. This is how I found it. Yay. Now find the other side. This is the one that's going online, by the way, because it ain't getting me taught next time. Okay, so what's this other leg called? What is it going to be? This is also 4 root 2. That's really simple, isn't it? What's this side? It is 8. How do I know it's 8? Because it's 4 root 2 root 2, isn't it? What's root 2 times root 2? 2. 2 times 4 is... Okay? You okay with that? Those ones are very simple. If you know the legs, the hypotenuse is really easy. Because you just put that in front of the root 2 and then you simplify, correct? Also, that's another way you could tell that's a 45, 45, 90, is that tells you that those angles are congruent. And the only time in a 90-degree angle that those could be congruent is when they are both 45, correct? Everybody with me there? So let's say this guy is 10. What's the legs? How'd you do that? That's pretty simple, but how'd you do that? Awesome. Okay, I'm not saying you didn't do that, but did everybody get that this is 5 root 2? I'm going to show you mathematically how to find it. Here's what I would do. What does 10 equal in our ratio triangle? And notice these other legs are x, aren't they, in our ratio triangle? So all I do is solve for x. So therefore I divide the root 2 over, as Kennedy said, right? But I don't like radicals downstairs, right? So I have to rationalize. So therefore that's 10 root 2 over 2 equals x, which is x is 5. Now, James thought about that a lot quicker than the way I did it, right? That's fine. But is it always going to be as easy as James just had? No. Like, for example, this guy is root 7. Can't see him as easy, can you? So that's why I understood and I appreciate the method you just did. It works sometimes, not every time, right? That's what math, I love about math. There's different ways to find it, right? But at the same time, there is a way that will work every time. Okay. Oh, sorry. I got to do something to make that work. No. Thank you, Say. That is actually very important, right? So, anybody have an idea of what we're going to do? Square root of 7 equals x root 2, right? You're just taking shortcuts, but yes. I'm not saying it's not true. It's true. I'm not saying it's not. I'm just, not everybody can think like that. Right? So therefore, root 2 top and bottom is root 14 over 2 equals x, and that's what these side lengths become. We feel comfortable about these? Not too bad, right? Yep. Now, do is, now we're going to talk about another special triangle. It's called the 30, 60, 90. But how to prove this triangle, we are going to prove it from, first off, an equilateral triangle. Does everybody know what an equilateral triangle is? What does that mean? All sides are equal, therefore all angles are equal, therefore all angles are 60 degrees. Okay. Where this theorem comes from is such. Okay? If this guy is x, what's this guy going to be? X and x. Okay. So what we're going to do is we're going to create a perpendicular bisector. I don't know if you guys remember that. What a perpendicular bisector is, it goes through this angle and it comes right through it, bisects this, so instead of this guy being x, this length right here is how much? X over 2. That's half of it. What's this amount? X over 2. Does everybody see that? Okay. What a perpendicular bisector does as well is it cuts this angle in half. So instead of him being 60, this is now 30 and 30. And what does the definition of perpendicular mean? The two lines intersect at a 90-degree angle. Okay? Notice, you guys see the 30, 60, 90 triangle. So, this is what I have. But I don't want to mess around with x over 2, so I'm going to call him x. If he's x, what would this length be? 2x. Does everybody understand that? Because if I just times him by 2, then I would times him by 2. Just so I can have x and 1 down here, because I don't want to play around with fractions. Yes. This guy would be x. And then it makes it a little bit nicer to find this other side. How are we going to find that other side? Pythagorean theorem. Were you guys taught these angles, triangles?
What's the angle?
That's 60, sorry. So then I have x squared, we'll leave him as b right now, plus b squared equals 2x squared, which is 4x squared. Did everybody see that? Yes, sir. Well, A, B, C, I don't know about what. Okay, because I don't know what this side length is yet. This C. You okay with that? Okay. I want B by himself, so I'm subtracting him over. B squared equals 3x squared. We want B's value. Correct? So B is x root 3. Yep. Good. Anybody have a question? So now we're going to play around with this. Knowing that we have a 60, 30, 90. This guy was x root 3. This guy was x. This guy is 2x. If I gave you this, find the rest of the triangle. You'd be interested in more. You're getting sassy in your older age. Really. Huh? 2 years. Did I not have you your sophomore year? Yes. Yes. What does this side correspond to? The 2x, the x, or the x root 3? It's x. You got flip-flopped, right? Notice, the 30, the opposite side is always x. So, look what we have, the side opposite of 30, so therefore this is equivalent to x. So this is actually the easiest style we could have, because this is then just 4 root 3 and this is because x is 4. Because that's the side opposite of 30. You with me on that? So therefore I can just say, oh, because x is 4, that's 4 root 3, and that is 2 times 4, which is 8. You with me? Then I could have a problem that looks like this. Don't even use the machine. What is that 15 equivalent to? It's equal to the 2x. So therefore, x is, are you freaking kidding me? 15x. Just divided by 2, right? And that goes here or here? On the side opposite of 30 is 15 over 2. Okay, what is the bottom side for us, or the side opposite of 60 in this case? Or 15 root 3 over 2. Pretty simple. What other kind of problem can we have? So far, notice I gave you the x value, I gave you the 2x value. What's the other style? I give you something that's equivalent to the x root 3 style, right? What was so cool about that shirt that your sister tweeted about?
Oh, she remembered.
What's wrong with that? Is her sister is a Twitter follower of mine,
Oh, yeah.
or vice versa. She is. She's in. Yes.
She won a shirt signed by the team of cast going into my birthday.
That's who they were. I don't know these guys.
Yeah.
Sorry, get that freaking by. Did you? I don't remember that one. Did I comment on that? Oh, maybe. Okay. Sorry. Huh? I'm excited. I have a good time. I'm not really that creepy, people. I don't like sleep for hours checking your stuff out. Maybe 30 minutes, okay? Huh? I tell you, it takes bathroom breaks from 3 minutes to 20. Mental picture.
I don't think people should bring their phone home. That's all.
Somewhat understand, but I used to
They
have.
say your phone's
Okay.
one of the most bacteria
I would agree.
every surface.
I used to, when I was younger, we used to have a plate. Boy, that sounded really bad. Game Boy. That was recording you. Oh, yeah, we used to have that back on the back. Yes, that just recorded. Really, we didn't have those. That we lived in a very. Oh, sorry. No, a Game Boy. Sorry. That's a little embarrassing. No, please don't do that one.
Tweeted off favorite.
That sounds really bad. Okay. Anyway, what does this guy equal? Let's just, anyway, we used to have a Game Boy on the back of our toilet. That was horrible. Insert foot. Anyway, well, that's like probably almost my most embarrassing thing I've ever said in my life. And it didn't even happen.
That's pretty good.
Not kind of. I wouldn't wear it. I'm not a t-shirt guy. Anyway, so notice I divide it because I want to know what x is, right? Okay, so therefore 12 over, horrible. Okay, 12 root 3 over 3, do that.
I'd just like to
You can just times by root 3 divided by 3, yes. Is that what you're going to say? I'm showing you a way, once again, showing you a way that works every time that you don't necessarily see it as easy, right? That's the key goal. When I'm trying to show you, do I understand there's easier ways to do things? I do, I really do. But I'm trying to show you that works every time, okay? All right, so therefore, this guy is 4 root 3, and this guy up here would be
Oh. About the
8
third
root
root?
3.
Yeah.
Because we double it, right?
It was like,
Okay, that's special triangles, okay? We can do a lot of stuff from those special triangles. Whoa!
how, I thought I'd be able to get it, but I'm not understanding how you're getting the 8 root.
The 8 root 3.
Yeah, like I don't know
Okay,
how
so
you're getting-
notice, that's a key question. If you don't understand that, that's a big, actually big
Yeah.
question. Okay, thank you for asking. So first off, sorry, I'm not trying to just, the key thing, this guy's x, this guy's x root 3, and this guy is 2x in our ratio
So
triangle, right?
is X always opposite?
Always opposite of 30. So
Okay.
therefore, this side was equal to the x root 3. Because see how that's the side opposite of 60? And see how the side
okay.
always opposite of 60 is x root 3.
Okay.
You with me now?
Yeah, I know.
Okay, so 12 equals x root 3. Solve for it, and I find x, because if I know x, I know the whole triangle,
Okay.
right? And x is always the side opposite of 30. It's here. And then notice the hypotenuse is 2 times our x value, but our x value is 4 root 3, so therefore 2 times that, which is 8.
Okay. That makes more sense. Thank you.
No problem. We feel okay? All right, so basically I've showed you some of your homework, okay? Some of your homework is also, did last year you guys learn, let me hear you just go,
Just
I know, you guys want me to just, and then you tweet your little heart out, your little tweet. I don't tweet at all. Really, I
everybody
don't.
else's.
I just read. I favorite a lot of shit. I'm glad. That's a good thing. 'Cause we don't want to have negative.
Don't laugh, we are talking about
I'm not thinking.
Okay,
of
solve that
everything.
triangle. I'll be back. She's my baby cousin. She actually just graduated high school. But I can't say a lot. I got married pretty youngish. I went to 2 years of school, but I was 20. My wife was 19, barely.
Oh, well, that makes sense.
that means it's
Hey, Cooper!
Sounds fun today.
Thank you. This would be 25 root 14 over 2. And that would be the 2 sides, correct? Okay, we feel decent?
Yeah.
How many of you guys remember the 6 trig functions from last year?
Sine, cosine, tangent, cotangent,
I have it
cosecant,
written
secant.
in.
Shut up, okay? That was just a blur. Here we go. I like these 6. This is the order I like to do it. Sine of theta is, how do you remember that?
Sokotoa.
So, ka, toa. If you had Miss Spangler, she probably told you about some old hippie caught a hippie tripping on apples. I say,
I don't even
I know
know
it's.
what those
I'm
are.
not talking about drugs in my classroom. Just dirty magazines. Okay? Right? Anyway, some old hippie caught a hippie tripping on acorns. Exactly. Some old hippie caught a hippie tripping on acid/apples. Okay? Many different ways, just SOHCAHTOA. So is opposite over hypotenuse. The ka is what?
Adjacent over
Cosine of
hypotenuse.
theta. Please don't call this sin and cos. I will slap you. Okay? That is one of my biggest pet peeves. sin to do math, okay? This would be adjacent over hypotenuse. And I really wouldn't slap you, but you get the idea.
Figuratively.
Tangent of theta
Opposite
is
over adjacent.
opposite over adjacent. Now, please understand, you guys also know what tangent is. It is also sine over cosine.
I like the 2D one.
That's what we're talking about in just a minute. So, do you know who goes with sine? It is. And the way I remember it, this is telling me, because you hear co, you think it goes with cosine, right?
I know.
That's how I always thought, but I'm like, the co's don't go. That's how I had to remember. The co's don't go together. So you have to throw that a little bit sassy. Try it again, James. I'll take it. So cosecant, which is the same thing as, by the way, 1 over. I need to put a theta in here. Sorry. You will be doing identities, I think, later.
Like Pythagorean method.
Oh, that's yes. That'll. But hey, give me a shot.
Okay.
Give me a shot.
I'm scared.
Okay, is hypotenuse over opposite, right? Is everybody okay? Okay. Cosine is secant of theta, which is, once again, 1 over cosine of theta, right? So therefore it is equivalent to your hypotenuse over adjacent. That's good, especially has some good colors in it, right? Purple and right. Oh, and then thank you.
You're welcome. You're welcome.
Cotangent of theta, I get off. I caught it. 1 over tangent of theta, which is adjacent over opposite. Or cotangent, the same thing as cosine of theta over sine of theta. Okay? How many of you guys somewhat recall these things? Pretty simple. So that's not asking a lot more to do, let's be honest, right? Kind of just brush that cobweb out of the attic.
The dark thing. That's what I put. The dark thing.
Okay. So now, when I give you any right triangle, right, I can find 6 trig functions, can't I? Does that make sense?
Yes.
So, let's kind of see some things that I'm going to ask. Oh, yeah. Right. Yeah, got this one. Woo! What are you doing? That I would, yeah. Whoa.
I just said one more thing. Oh. You can sit right here if you want.
You sure? You don't take notes?
I do take notes. Haven't you been watching me paying attention?
Okay.
As far as that goes, we watch that's it.
Sign language?
As far as it goes.
Don't you love that show?
Yes.
I actually love that.
What's up?
Don't you think the one deaf girl's a little pansy?
What the death
But Bailey, I've never liked her. Is her Bailey?
Like
Bae.
Bae.
Oh, she's
I
Bae.
love Babe's face so bad.
I just
Oh
sit
my
there and I'm
gosh,
like,
I'm just kidding.
You are pathetic.
Except
Except for this last thing.
Nightmare child.
Exactly. She is like that, and then, like, this is the only good thing she's ever done. Look what's happening right here. I don't want to ruin it for anyone.
Dude, I've been waiting for a long time for this.
I actually asked Parker some of the signs, and he's like, that's wrong.
Are you serious?
Uh-huh.
Yeah, they do. They
Yeah.
say that.
It's
Well,
not
she's
all the way.
really deaf and fucking bad.
The boy in it though is.
Okay, because I thought she was talking better.
I was gonna say, I heard she was. Anyway, let's go back. Let's find the 6 trig functions of theta. So once again, that sine. Wow, that's sine of theta, cosine of theta. If you find these 3, isn't the other guys really simple to come along? Because therefore, then this guy over here is cosecant of theta, secant of theta, and cotangent of theta, right? Okay, so what is that third side? We need all three sides, correct? So, did you already do it by chance? What did you get? This guy came out to be 17. Do I need to show that, or you guys feel comfortable doing that? Because I did 15 squared, which is 225, plus 8 squared, which is 64, equals c squared, which is 2. That was pretty simple, actually. See this stuff. Okay, so that's where that comes from. So therefore, let's go right here. What do you got for sine of theta? You know? Okay. So if I stand here, remember sine was opposite over hypotenuse. 8 over 17. You okay there? Okay, so therefore, cosecant would be really simple to find the other guy when you have him, right? Okay. How about cosine of theta? What are you going to get? 15, because that is the adjacent side if I'm standing here in this angle, right? What if I was up here? Who's your adjacent? The 8 would be. Does that make sense how the adjacent and the opposite can flip-flop, right? Depending on where you're at. Can the hypotenuse ever move? Okay, so that'd be 15 over 17, so therefore secant is 17 over 15. Okay, tangent of theta is opposite over adjacent. So 15 over 8 and 8 over 15. What?
Yeah, I was gonna say.
Come on.
Hey, can I take notes?
Oh, I'm looking at this.
Oh, shiz, yeah, I just
Yeah. You're welcome.
Isn't
because I was doing it at that top angle. I was looking at this, yeah. So, okay, so equals, you're right, because I'm standing technically here, huh? I kept speaking. It's okay. So, opposite is 8 over 15, and,
When it gets to these numbers, I always
yeah, it'll tell you it's right. Okay, can we do this stuff? That's about, which you might have to be able to rationalize. Meaning if this was root 8, first off you gotta simplify and rationalize. The root 8 could be 2 root 2, right? Be aware of those. I'm not saying there are a lot in there, but we've done rationalizing in the past. Okay? Just seeing if we went through everything basically. Okay. So, do you guys understand that on, I need to hear you talk about this, that on my special triangles, okay, here's my 45, 45, 90. This guy was x, x, x root 2. Yes, sir. True. Okay, so with this being said, what if I said sine of 45? If I ask you what is the sine of 45? Let's say I'm standing here. This doesn't really matter. You can all do the same. So that would be opposite, which is x, over x root 2, which is 1 over root 2, because x over x would reduce out. You know sine of 45, once again, it's a unit circle thing. I'm not afraid of moving into that. This will always be root 2 over 2, no matter what your triangle is, because this ratio will always simplify, right, to be 1 over root 2, which is root 2 over 2. Correct? Everybody there with me? So,
That's
one,
not as bad.
that's where unit circle came from. And I will show you next time more about it. So, now we do our 30, 60, 90. Notice, by the way, cosine of 45 is still root 2 over 2. What's the tangent of 45? X over x, which is always will be 1. Right? Okay? So, if I do here, this guy would be x, x root 3. Give it a distraction. What is the cosine of 30. You are!
Dude, I'm just chilling.
I know, but it doesn't mean that you're not distracted. When you're as handsome as you are, I'd look over at you too.
That was funny. I'll see you later, silver buttons.
So I'm sitting here at 30. Who's my Jason? X root 3 over 2x, because it's adjacent over hypotenuse, right? The x's, and so this will always be root 3 over 2. So notice, the special triangles, that's another reasoning, is they will always have specific ratios, won't they? That's why they're kind of special too. There will always be these little cosine and cosine. Huh? You okay? Okay. We okay? Are we all right? Okay. So I think you should be able to fill that out. There's a little bit of that. A little bit of this. Some of that. I know. Because I'm a man. Isn't it a good time? I tell you, that's right here why I'm employed. Okay? I might not be a great teacher, but we can have a good time and have a little math. A little key point.
A little.
Anyway, let's say I want to find the distance across a river. Okay? Distance. Here's my river. Oh, my bridge is going to be brown. Is this brown?
Ew, that's really
It looks
ugly.
like mustard. Let's tell you really what that sucker is. Hey, that's actually a greenish color.
Really?
Anyway, so here is my bridge, and I know my bridge. Well, no, I don't. I don't know my bridge. I maybe need to buy my lumber for my bridge. Boom. Okay, but I know that I measured this distance. Oh! Okay, so I've measured this distance to be 100 feet. Okay, and there's a little itty bitty tree over yonder.
It's actually too simple to be honest.
That's actually
Is it though? Because we're going to cut that sucker down to make a bridge. Can't cut trees down either. I did not know that part. Sorry. Okay, so I get my little thingamajigger, okay, and I find out the angle between here. This is what a surveyor does. You guys know the surveyors, the people that sit out in the middle of the street with their machine. That's called a surveyor. You guys have never seen that?
Wait, in the middle of the what?
They sit out in the middle of the street and they have like that tripod thing, and he's always looking at it, and they have the guy a little bit down with the stick. Never?
Yeah.
That's a surveyor.
Like in the middle of a street. Like
A lot of times they'll do it to get, huh? Well, it's because I've lived for 32 years as well, and I don't keep my face like this when I'm driving around with other people. Your generation's missing out.
A surveyor.
I'm telling you, I can't believe you guys don't know what a surveyor is. 54 degrees. Do you know who it is for? Right over there. So what's the length of the bridge? How are we going to do that? Because we don't have two sides to get a third, right? You might want to come back to get it or get it from somebody else. Huh? It's not physics, it's trig. Nope. Yeah, there you go. Go. Not tangent 100. Because I'm missing this side, right? What's this side represent? What does this side represent? Opposite and adjacent. Which trig function uses this angle and opposite and adjacent? Tangent. So I do. Tangent of 54 degrees equals x over a hundy. A hundy. So how do I get rid of the hundy just to have an x? You give them a hundy. Mock my tree cutting. I'm just playing. So, first off, I want to make sure you guys understand. Go to the machine.
You are hungry.
You need to make sure your mode is in degree. Because we are talking about degrees right now, huh? Isn't that 54 degrees I just said? So we go down, down, down. Right where did it go? Right up.
Yeah, I got the same answer as the book.
Okay, so then I go 100 tangent of 54 is a lovely, that bridge is 137.6 something feet. Your homework is going to be. What is your homework? What is your homework? Okay, your homework is starting on page, don't know yet, 308. So once again, please write 4-3, page 308. Ooh, I wonder, we might need to go over that really quick. 1 through 31 odd. That's not that bad.
It looks like a lot.
So technically it's 30.
Some are
Not all of them. I don't care about that. 53 through 67.
You got this one.
Yep, the only thing that I need to hurry and talk about that I did not give examples, so obviously you guys would like an example.
Why is your room so cold?
I like it cold.
Yeah, dude.
It's like warmer outside than it is in.
Awesome, I appreciate that. Okay, fun. Let's say I have my secant of theta to be 9/5. What's the... Yeah, well...
Looks like a great event.
So
You can tolerate my people's
You can tolerate what? I have a lot of sarcasm.
No, do I really? It's okay, dude.
you hate sarcasm.
I do, a lot. My wife gives me sarcasm and I share. And I'm like, what? Like today, her parents are pissing her off. She's like, how are you? Just peachy. I'm like, makes me so frustrated. Okay, I want to find the rest of the 6 trig functions. So I got one, I want the others. Okay? So, here we go. Draw a triangle. Here's theta. Right? But remember, secant is hypotenuse over adjacent. Right? So therefore, if I'm standing here, this would be 9 over 5. You could do cosine straight up. Yeah, that's fine. Because we can already, if you know this, we got cosine straight up as well, right? It's 5 now. And if it's easier to remember cosine than secant, that's great. Okay. Is everybody okay with that? How do we get this other side? Good old Pythagoras, right? 5 squared plus b squared equals 81. We're 81 and 25, so therefore b squared equals 81 minus 25, which is 56. Which then I need to simplify that sucker. It'd be 2 root 14, I believe. 2 root 14. I want to say that. Is that?
Let's just